So, good evening, everyone. And this unit 1 in LCS, and the topic is mechanical translational system. And the problem is determine the transfer function of the given system, that is x into s divided by f into s, and x into s divided by f into s for the system. So, you can see the diagram. It has two masses m1 and m2, and the acting force is F of T in M1, and the opposing forces are a spring is acting as K1, and the dashpot is B1, and dashpot is connected across M1 and M2, that is indicated as B12. So first of all, we have to convert this particular mass M1 into free body diagram, and after this one we have to calculating the equation, we have to go for M2. So first is the free body diagram. Here you can see the F of T is acting as the force in M1, and the remaining thing, the F of M1, the forces opposing force from mass 1, that is indicated as F into M1, and the K the spring that is acting in M1, that is indicated as F into K1, and B1 uh, which is a dashpot, so that is indicated as the F into B1, and the common dashpot which is denoted as F into B12. So the acting force is equal to the opposing force, which we have mentioned here. This is the acting force, and they are the opposing force. So F into M1 plus F into B1, F into B12, F into K1, that is equal to F of T. So these values for M1 we have to um, uh, derivate this two times. So we are putting m into d square x into dt square, that is x1 plus for dashboard we have to derivate one time, so b1 into dx1 divided by dt, and for the dashboard 2, b into 1 to d x1 minus x2 divided by dt. So and for this remaining k plus k1 into x1, that is equal to f of t. This is we are getting this equation, and after this we have to take Laplace transform for this equation. So when we take Laplace transform, the t domain converts into the s domain. So m1 s square x1 into s plus b1 into s x1 s plus b12 s and s into x1 s minus x2 s plus k x s is equal to f of x. So after simplifying this, we are taking the x1 s out, and we'll get m1 s square plus b1 s plus b12 plus k1 minus b12 s s x2s, that is equal to f1. We are keeping this equation as m1. So for the first mass 1, the equation is this one. So then we have to go for the m2. So m2, so the opposing force in m2 was fm2, which is the force opposing force given by the mass m2, and fb2 the dashpot which is opposing, and fb12 which is the dashpot acting between m1 and m2, and f into k2 the spring acting in the mass m2, that is equal to 0, because the force the applied force is only applied to the m1, so we are keeping this as 0. Similarly, we have to take expand this. For the mass we have to derive this two times, so dx x2 divided by dt square, and for the dashpot b2 into dx 2 divided by dt, and for the common dash part b12 d by dt x2 minus x1 plus k2 minus x1, that is equal to 0. We are taking Laplace transform for this equation, and we will get m2 x square x2x plus b2x s into x2s plus b12s x2 minus s minus x1 into s plus k2 x2 into s, that is equal to 0. So after simplifying this one, we are taking the x2s out and we'll get this equation m2x square b2s plus b12s plus k2 minus b12 x into x1s, that is equal to 0. So keeping this x2 on the left side um, and taking this b2 x into x1 to the other side, this becomes positive, and after that you keeping this m2 moving this to right side, and it goes to the denominator, and we keeping this equation as m2. So now we got the value for x2 into s. So we have to substitute this equation 1 and equation 2. So substituting 2 in 1. um, so so this is our equation number 1. So this is our equation, and we are substituting this value, that is x2 of x, we are substituting in the this equation. I will get x1 into s f of x equal to m2 s square plus b2 plus b12 into s plus k2, and m1 s square plus b1 plus b2 s plus bz square b1 s plus k2 minus b12, that is whole square. So after simplifying these values, we'll get that x1 into s value, that is x2s to m2s square plus b2 plus b1 s plus k2 and divided by b12 whole square. So substituting this 3 value in 1, this 3 in 1, so we're getting this equation, and finally simplification will get the value of x2. We are identifying x1 by f of x here, and we are identifying x2 of x divided by f of x here. So these are the two values which are no indicated in the question. We have identified two of the answers. Thank you.